Assalamualaikum and very good morning to everyone. Glad to see you guys in this semester. I'm Cik Azika Cik Hussein, your mathematics lecturer at PPST. This week we will cover chapter 3, the topic of system of linear equations. Let's get started with the objective of this topic. At the end of the lesson, students should be able to write given information in the form of matrix. You can write a system of linear equations in the form of ax equal to b. You can discuss system of linear equations and the type of solution, namely unique, inconsistent, and infinite solutions. The linear systems of matrix equations. We consider the system of linear equations with three unknown for x1, x2, and x3. All the linear systems above can be written as a single matrix equation, like this one. Okay, this one A11, A22, A12, A13. Means this one is the row, and then the second one is the column. This is the first row, and then this is the second column, first row, and then the third column. This one, the value of x, x1, x2, and x3. This is the solution. Okay, B1, B2, and B3. Which is A and B, X, X1, X2, and X3. Thus, the system of linear equation can be written as A times X equal to B. Okay, this one, A times X equal to B. For example 1, Lily wants to buy 3 different flavors of ice cream for her children. For the first child, she buys ice cream which costs Rm2 for a scoop of strawberry, and then Rm3 for a scoop of vanilla, and then Rm4 for a scoop of chocolate. For the second child, this is the first child, and then the second child, she buys ice cream which costs Rm4, Rm3, and Rm1 for each strawberry, vanilla, and chocolate. Meanwhile, for the third child, the cost is Rm1, Rm2, and Rm4 for strawberry, vanilla, and chocolate respectively. She buys X scoop for strawberry, Y the scoop of vanilla, and then Z is the scoop for chocolate. Write down the system of equations if she spends Rm34 for the first child, and then Rm28 for the second one, and then Rm27 for the third child. So for the solution, this is the first child. We have 2 scoop of the strawberry, then the 3 scoop of the vanilla, and then 4 scoop for ice cream, chocolate ice cream. This is for the second child, and then the third row is for the third child. The system of Ax equal to B is called consistent if it has solution, infinitely many, or unique solution. Okay, if it is inconsistent, it has no solution. Types of solution of linear system equation in a two-dimensional geometry. it is consistent if it is unique and infinite many, it has solution. And then inconsistent if it has no solution. Okay, we look at example for unique solution. Solve the system of the equation like this. Okay, we have first equation and then second equation. If we have more than one equation, we can call as the system of equation. So from here, we want to cancel out the value of y. So means we need to add the first equation and then the second equation. So 5 plus 6x, we can get 11x. And then this one we can cancel out. 22 plus 0 equal to 22. And then the value of x equal to 2. And then we substitute the value of x equal to 2 into the second equation, for example. And then we can get the value of y equal to 6. There is only one intersection point at 2 and 6. This is for x and then this is for y. Thus, it has a unique solution. Okay, we continue. We look at another example. Example 3, we have system of equation. Okay, we look at here. We want to cancel out the value of y. We need to add the first equation and then the second equation. Add this one, 2 plus 1, we can get 3. So 1. So x equal to 1 over 3. Then we substitute the value of x equal to 1 over 3 into this equation. We can get the value of y 2 over 3. So the system has unique solution. We only have one intersection point, right? For infinite solution, in example 4, we solve the system of equation. Here, we know that y equal to 3 minus 2x. We substitute y into the second equation. And then we try to solve this one. So, 0x equal to 0 means the value of x can be any value. So, x has many solutions. X can be 1, x can be 2, x can be 3, and so on. So, therefore, x has many solutions. Let's say we let x equal to t and y equal to 3 minus 2x. So, y equal to 3 minus 2t. Okay, we substitute here. And t element of real number. Therefore, we can say that x has many solutions. There are infinitely many points of intersection, thus it has infinitely many solutions because x can be any real number. Alright? In example 5, we try to solve the system of equation by substituting the value of x here into this equation, the second equation, and then we can get 0y equal to 0. The same thing like example before. We let x equal to t, for example, y equal to x minus 2. Okay, so y equal to t minus 2, t element of real number. So therefore, x has many solutions. We continue with the inconsistent solution. In example 6, we need to solve the system of equation. Okay, for this one, we want to cancel out the value of x, the variable x. Okay, and then for the first equation, we multiply with 3. And then the second equation we multiply by 2. We want to cancel out, so we multiply with -2. So here 12 minus 12 will be 0, so we can cancel out. And then 6 times 3 we get 18. 9 times -2 we can get -18. So we solve this equation, this system of equation to get the value of y. So here we can see positive 18 minus 18 would be 0, right? So is it true here? 0 equal to 12? False, right? So we can say that there are no points of intersection, thus it has no solution, or also known as having an inconsistent solution. If it is inconsistent, means there is no solution. Okay, we look at example 7. Solve the system of equation. This one. We want to cancel out the variable of y. So we need to multiply by -2. So -4x plus -2 times negative, we will get positive 2y. So we can cancel out the variable x and then cancel out the variable y. So here 0 not equal to 1. So the system has no solution. So as conclusion, the system of linear equation can be written as ax equal to b. Then the type of solution of linear system equation of ax equal to b is called as consistent and inconsistent. If it is consistent, it has unique and infinitely many solutions. It is inconsistent if it has no solution. Okay, for part 2, how to use inverse matrix in solving ax equal to b. By using the inverse matrix method in solving systems of linear equations, if the number of equations in a system equals to the number of variables and the coefficient matrix has an inverse, then the system will always have a unique solution that can be found by using the inverse of the coefficient matrix. Okay, for example, here we know that ax equal to b, then x equal to a inverse times b. For the proof, okay, this is for 3 times 3 square matrix. We multiply with a inverse for the left hand side and then a inverse for the right hand side. Okay, we can multiply here. So a inverse times a equal to identity matrix. Okay, identity matrix is like this: 1 0 0 0 1 0 for 3 times 3, 0 0 1. Okay, so x is equal to a inverse times b. Remember that we can find the inverse of a matrix by using adjoint method or the properties and elementary row operation. You have learned this one for the topic of matrices. Okay, we look at example 1. We solve the equations by using the inverse matrix method. 3x1 plus x2 plus 2x3 plus 11 equal to 11. Okay, we need to solve this one. Okay, we convert to in the form ax equal to b. So here how this one is the inverse 1 over determinant of A. How to find the determinant of A? This one, first of all, okay, let me show to you. Okay, just now we have 3, 1, 2, 3, 2, 2, 1, 0, 1. Right. We want to get the inverse matrix. The formula must be the determinant of this. We let this one is this matrix as A. Okay, the determinant of A, 1 over determinant of A. And then we need to find the matrix of minus. Do you still remember that? For example, here we cancel out the first row and then the first column. So 2 times 1 equal to 2, and then minus 2 times 0, so equal to 2, plus minus plus. Okay, and then equal to 2 here, the first row and then the second column. 3 times 1 equal to 3, minus 2 times 1 equal to 2. 3 minus 2 equal to 1, right? Equal to 1. But here plus minus plus, right? So here must be negative 1. And then we cancel out the first row and then the third column. 3 times 0 equal to 0, minus 2 times 1 equal to 2. So minus 2. Minus 2, okay. And then the next, okay, 1 times 1, 1, minus 2 times 0, 0. So here 1, but here the coefficient of the cofactors must be, here must be minus, so negative 1. And then second row and then the second column. 3 times 1, 3, minus 2, we can get 1. And then the third one here, 3 times 0, 3 times 0, 0. 1 times 1 equal to 1. But here negative plus negative. So negative 3 times 0, 0. Minus minus positive. So here will be positive. Okay. And then the last one, the third column, in the first row, 1 times 2, 2. 2 minus 2 times 2, 4. So 2 minus 4 equal to -2. Okay. So here -2. Third column, third row, the second column, 3 times 2, 6. 6 minus 6, 0. And then the third row, and then the third column, 3 times 2, 6 minus 1 times 3, 3. 6 minus 3 equal to 3. Okay. And then we have B just now is 11, 10 and 5. This is the cofactors. So how to find the 1 over A, the adjugate the transpose of cofactors. To get the conjugate, the transpose of cofactors, also we call as adjoint. So that means the first row, it will be the first column of the transpose. The second row will be the second column. And then the third row will be the third column. Okay. To get the determinant of A, from here, 3, right? 3 times, cancel out, 2, 2, 0, 1, minus, we use the first row, 1, cancel out here, 3, 1, cancel out here, 3, 2, 1, 1. Then the last one, the first row, 2, cancel out here, 3, 2, 1, 0. Okay, it can be 2 times 1, 2 minus 0 will be 2 minus 3 times 1, 3 minus 2 plus 2, 3 times 0, 0 minus 2 times 1, 2. So it can be here 6 minus 1 minus 4 equal to 1. So 1 over 1. Okay, 1 over 1. The determinant 1 over 1. Okay, we continue. That's why here we get 1 over 1. This is the adjugate just now. 2, -1, -2, -1, 1, 0, -2, 1 and 3. Then we get here 2, -1, -2, -1, 1, 0, -2, 1 and 3 because we multiply with 1. So we need to multiply with x equal to A inverse equal times B. Then we can get the value of x1 equal to 2, x2 equal to -1 and x3 equal to 3. In example 2, we need to find A times B and A inverse and solve the following linear equation. This one. Okay, A times B means here 3 times 3, 3 times 3, so the solution would be also 3 times 3, right? Here we get 16, 0, 0, 0, 16, 0, 0, 0, 16. It also can be 16 identity, because identity is 1, 0, 0, 0, 1, 0, 0, 0, 1. Since AB equal to 16i, I is the identity, so A inverse is 1 over 16b. We know just now that the value of B here, because AX equal to B, right? So the value of B is like this, okay? So we substitute, you can get 1 over 16 times B. Then we need to solve the system of equation in the form of AX equal to B. So this one, the A transpose times X equal to P, and then we multiply with the inverse of the transpose for the left hand side and the right hand side. Okay, we can get X equal to A transpose inverse times P. So just now we get the transpose of A, sorry, the inverse, okay, 1, 2, -1, 3, -1, 0, 0, 3, 1. This is the transpose one, because just now we get the value of X. Do you still remember that A inverse equal to 1 over 16b? 1 over 16, 1, 3, 0, 2, -1, 3, -1, 0, 1. So we transpose this one. Okay, the first row can be the first column. The second row can be the second column. The third row can be the third column. Okay, we can get the solution. X equal to 1, Y equal to 1, and Z equal to 1. In example 3, given A, the matrix A, find A square minus 6A plus 11I, with I is identity matrix 3 times 3. Show that A times this one equal to 6I. Hence reduce to A inverse. Okay, we look at the solution. Okay, this one, A times A minus 6A plus 11I. Okay, can you solve this one? Can get here 4, -1, -2, -2, 5, and -2, 2, -2, and 2. So therefore here this is A, okay, This one is a square minus 6a plus 11i equal to 6i. So it is proven. Okay, we let a square minus 6a plus 11i as b. So a times b equal to 6i. Okay, the solution just now we get 6i. So we multiply with a inverse for the left hand side and then the right hand side. This one can cancel out, we can get inverse, we can get the identity. So 6a inverse times identity, so a inverse equal to 1 over 6b. Okay, this is this one by using the properties. So as a conclusion, Ax equal to P for 3 times 3 square matrix. A inverse times Ax equal to A inverse B. Then A inverse times Ax equal to A inverse B. And then A inverse is the identity matrix. X equal to A inverse B. Can do the exercise. So we continue to the Gauss-Jordan elimination method. By using the Gauss-Jordan elimination method in solving systems of linear equations, the procedure: write the equation of Ax equal to B in the form of the augmented matrix A and B. Use elementary row operation to reduce the augmented matrix to form a reduced augmented matrix RAM. The augmented matrix A, and then the second part is B, which is we need to make it is reduced augmented matrix like this. We also call as RAM. We need to make A must be identity. Okay, this one A is identity, and then B is we can get the solution here. Identity matrix and the solution matrix. For example 1, solve the following system of linear equations using Gauss-Jordan elimination method. We can need to change to for linear equation for the system of linear equation in matrix form. Okay, this one x, 2x, -3, 1 and -1, 1, 1, 1, and then this is A, this is B. We need to change to I, and then we get the solution matrix. Okay, first of all, we know that it must be identity, right? 0, 1, 0, 0, 0, 1. So since here 1 and then this is also 1, so we no need to do anything for the first row, and then we need to reduce this one to 0. Okay, for the second row. So this is the star here stand for the new row of R2. Okay, new row of R2, which is the negative R1 plus, okay, negative, you need to multiply with negative. Negative R is means row. Negative row 1 plus row 2. So negative 1 plus 1, we can get 0. Okay, look at here. For the first row here, no need to change anything because here already 1. Okay, for the second row, we need to reduce to 0. right, by using the formula of the new row 2, negative R1 plus R2. So negative 1 plus 1 we can get 0. And then negative 3 times negative we get 3. 3 plus 1 you can get 4. Then negative 1 plus 1 can get 0. So negative 12 times negative we can get 12. 12 plus 0 equal to 12. So now we can get the R1 and the new row of R2. Here the next step we need to reduce to 0, right? Because we need to change to 1 0 0. Okay, so we need to reduce the third row to 0. So the new row R3 equal to negative 2 R1 plus R3. Okay, we must make the third row equal to 0. So negative 2 times 1 equal to negative 2. Negative 2 plus 2, it will be 0. Okay, next, negative 2 times negative 3 is 6. 6. Negative 3 times negative is 6. 6 plus 1 plus negative 1 you can get 5, right? 5. Okay, here 5. Okay, and then just now negative 2 times 1, negative 2, negative 2 plus 1, we get negative 1. So here we get here negative 1. Next, we need to make sure here must be 1 because we want to reduce to identity matrix. Okay, how to get this one? The second row, this one A22, the second row and the second column must be 1 by using the formula of 1 over 4 times R2. Okay, means 1 over 4 times 4, we can get 1. So we need to multiply all this formula to the second row. Okay, second gets here 0 1 0. 1 over 4 times 12 we can get 3. The next, here we need to reduce the third row. Here we need to reduce to 0 by using the formula R3 equal to negative 5 times R2. This is the new row. Negative 5 times R2 plus R3. So means negative 5 times 1 plus 5. So 0. It will be here 0. And then negative 5 times R2. R2 is 0. So 0, 0 plus negative 1 can be negative 1. Okay, negative 1. And then here the same thing by using the formula negative 5 R2. Okay, negative 5 times just now is 3. So negative 5 times 3 can be negative 15. Negative 15 plus 16 can be 1. Okay, that's why we get 1 here. Okay, again, we need to reduce to the identity matrix, but here must be equal to 1, not negative, right? So for the third row, the new one, we need to multiply with negative R3. So we multiply with negative, we can get here positive, and then this one negative. Okay, next, the second row, it's already positive 0, right? So no need to do anything for the second row, and then we proceed with the first row to make sure here the value of 1 here reduced to 0. So the first row, the new row here, how to get this one to be 0? By using, okay, negative R3, okay, negative R3 plus R1. So negative 1 plus 1 is 0. So you need to use this formula for all elements in the first row. So we can get the solution. And then next, we make sure here must be 0 by using the formula. The first row for the new formula, 3R2 times plus R1. So 3R2, R2 here. Okay, 3 times 1 is equal to 3. 3 plus negative 3 equals 0 here. That's why here we get 0. You need to apply this formula to all the elements in the first row. Okay. So therefore the solution is consistent or unique, that is x equal to negative 2, y equal to 3, and z equal to negative 1. Example 2, Ali, Bob and Ravi bought tickets for the 3 separate performances. The table below shows the number of tickets bought by each of them. We have Ali, Bob and Ravi, concert, orchestra and opera. Ali bought 2 concert, 1 orchestra and 1 opera. Bob bought the tickets for the 1 concert, 1 orchestra and 1 opera. Ravi bought 2 concert, 2 orchestra and 1 opera tickets. If the total cost for Ali was Rm 122, for Bob Rm 87 and Ravi Rm 146, represent this information in the form of 3 equations, okay, into the systems of linear equation. Okay, find the cost per ticket for each of the performances using Gauss-Jordan elimination method. Then the third one, determine how much it would cost Hassan to purchase 2 concert, okay, 1 orchestra and 3 opera tickets. Okay, for the first question, we let x, y, z. Okay, x is the price per this one, concert ticket, orchestra and opera. The 3 equations are for Ali just now. Ali, 2x plus y plus z equal to 122. For Bob, x plus y plus z equal to 87. And for Ravi, 2x plus 2y plus z equal to 146. So we change to this one. Okay, A and B. Okay, we need to use to solve the solution by using the Gauss-Jordan elimination method. We know that to make sure here to be identity, we need to interchange the first row and then the second row. Okay, so just now this is for the first row 2, 1, 1, and then when we interchange, we can get the first row 1, 1, 1. Okay, we interchange the row 1 and row 2. And then we need to reduce the row 2 to 0 by using negative 2R1 plus R2. Okay, this formula applied to all the elements in second row. And then to make sure here equal to 0, we use the formula of negative R1 plus R3. We can get here 0. This formula applied to all the elements in third row. Then we get here like this. we know that to get the identity here must be positive. So the new row must be multiplied with negative. And then the third row here also must be positive. Okay, bear in mind, first must be here 1, and then make sure the first column you need to solve first. Okay, make sure the first column must be 1 0 0, and then next the second row and then the second column must be 1, and then here must be 0, and then the next step, make sure here the third row and then the third column must be 1. Okay, so here the new row can multiply with negative to get positive, and then next here must be 0, next here 0, next here 0, the last one. Okay, that is the step. Okay, here must be 0, right? So since we have here 1 0 0 1 0 1, and then we need to make sure here we reduce to 0 by using the formula. The new row, okay, this one, the new row R2. Okay, this represent for the new row. Negative R3, okay, we consider this one negative R3 plus R2. So negative 1 plus 1 equal to 0. This formula applied to all the elements in the second row. And then next we need to make sure here the first row must be reduced to 0 by using the formula for the new row, negative R3 plus R1. Okay, this formula applied to all the elements in the first row. Okay, we get here the last one. We need to make sure the first row here must be reduced to 0 by using the formula the new row of R1. Okay, this one, the R1, we want to change here to 0. So negative R2, okay, negative R2 plus R1, okay, equal to 0. So this formula applied to all the elements in the first row. So now we get the identity, right? 1 0 0 1 0 1 0 0 0. So we get the solution here, x equal to 35, y equal to 24, and z equal to 28. Therefore, the cost for concert, RM 35 per ticket, orchestral 24 per ticket, and the opera 28 per ticket. The amount Hassan to pay for the tickets if he purchased 2 concerts and 1 orchestra and 3 opera, we need to multiply with this value. So 2 times 35 plus 1 times 24 plus 3 times 28, we get 178 ringgit. So as conclusion, the arithmetic matrix AB, we need to reduce arithmetic matrix RAM to identity, and then we can get the solution in the right hand side. Hi guys, we continue with the last subtopic for systems of linear equation, the Cramer's rule. At the end of the lesson, students should be able to apply the Cramer's rule to solve Ax equal to b. Using the Cramer's rule in solving systems of linear equation, we consider, okay, this one, which is Ax equal to b. The first step, we need to find the determinant of A, this matrix. The second step, to determine x1, we replace the first column of A by the entries of B. Okay, we need to find the determinant of A1 over determinant of A. The third step, to determine x2, we replace the second column of A by the entries of B. then the last step, to determine x3, we replace the third column of A by the entries of B. Okay, here, see, substitute here. Need to get the determinant of A3 over determinant of A. In Cramer's rule, we need to memorize this one. Okay, we look at the example. Write the system of equation AX equal to B. We need to find the determinant. Do you still remember how to find the determinant? Here just now we have, we create a note. We have A equal to 1, -1. So 1, 1, -3, 2, 3, 1. Okay. Here, actually here we can use any row or any column, but now I choose the first column as the entries to get the determinant. Okay, for example, here we have what plus, minus, plus. So 1, the minor is, we cancel the first column and then the first row. We can get 1, -3, 3 and 1. Okay. 1, -3, 3 and 1. Minus 1. The first column and then the second row. We get -2, -1, 2, 3 and 1. -1, 2, 3 and 1. Then the last one, the first column and then the third row. Okay, plus 2, -1, 2, 1, -3. So we can solve this one. We can multiply 1 plus 9 minus, okay, 1. -1 times 1 minus 2 times 3, 6. So -1 minus 6 plus 2. -1 minus times -3, we get 3 minus 2 times 1, 2. So we get here 19. By using the Cramer's rule formula, okay, we need to find the determinant of A1. Okay, we need to replace the first column by the entries of B. Okay, we need to find the determinant of A1. Here we need to replace the first column with entries of B here. So this one, we use the third row as the entries to get the determinant. Plus, minus, plus. Okay, so that's why here plus, minus, plus. You can solve this one. You can get -2. To get the value of x2, we replace the second column by entries of B. Okay, we use the first column here. You can use any column or any rows to get the entries of the determinant. Okay, and then we find the minor to solve this one. We can get the value of x2 is equal to 3. For x3, we need to replace the third column by the entries of b. Here, we use the first column, 1, -1, and 2. Okay, the cofactor plus minus plus can get equal to 4, x3. So x1, x2, and x3, get the solutions. In example 2, Zainun, Ashikin, and Aisha purchased textbooks from a bookshop. Zainun purchased an English and a mathematics textbook for a total of 226 ringgit. Nur Ashikin purchased 210 ringgit for a mathematics and biology textbook, while Aisha spent Rm200 for an English and a biology textbook. By using the Cramer's rule, find the price of each textbook. We need to simplify this long story to a timetable. Okay, timetable like this for the books, each English, Maths, Biology, Zainun, Ashikin, and Aisha. Then we let X as the price of English textbook, Y the price of Math textbook, and Z is the price of Biology textbook. We write in the system of equation AX equal to B, like this. Okay, we remember this formula. How to get determinant of A? We have just now the matrix of A is 1, 1, 0, 0, 1, 1, 1, 0, 1. Okay, we use the entries, the first column, for example, and then the first column, and then the first row, we will get 1, 1, 0, 1 minus 0 plus 1. We will get 1, 0, 1, 1. Okay, here we can 1 times 1, okay, minus 0, so plus 1, so that's why we get 2 here. And then to get x1, we replace b into this, the first column. Can get x1 as 108. For x2, the second column we replace with the entries of b, and then we get 118. For x3, the third column we replace with entries of b, then find the determinant of A3 over determinant of A. We have the determinant of A is 2, and then x3 is 92. So as conclusion, for Cramer's rule, we need to memorize this formula for x1, x2, and x3. Okay, the consistent system of equation can be solved by using the inverse matrix, the Gauss-Jordan elimination method, and Cramer's rule. The inverse matrix we have just now by using minor, cofactor, and adjoint, right? The Gauss-Jordan elimination method, and then the Cramer's rule. Okay, that's all. Thank you.